Welcome back to Basic Mathematics. In this video, we're going to be looking at long division and how long division works around decimal numbers. So without further ado, let me get my head out of the way and let's dive right in. The process of division with decimal numbers actually works the same as the process of division with other numbers. It just feels like it's scary because it's decimal numbers. Let's start with something that just has whole numbers in it, a relatively simple problem like 15 divided by 4. We could set this up in a long division box. 4 fits into 15. We know that 4 fits into 15 3 times. 3 times 4 is 12, and when you subtract 15 minus 12, you get 3. You could say that this is 15 divided by 4 is 3 with a remainder of 3. You could write this as the mixed number. 15 divided by 4 is 3 3/4. But today we want to talk about decimal numbers. So we make the conscious choice to declare that 15 is a decimal number. Trailing zeros at the end of a decimal number don't change anything, so we can introduce that without any issue. Now we're going to say that we're dividing 15.0 by 4. The reason that that's useful is it gives us an extra digit to drop down. And now we can continue our story. 4 fits into 30. Well, that's going to fit 7 times. 7 times 4 is 28, and you subtract that off and you get 2. We can introduce another 0 and drop it down and repeat one more time. 4 goes into 20 5 times. 5 times 4 is 20. Subtract that off and you get 0. Our remainder is 0. We could introduce more zeros and keep dropping them down, but you're still going to end up with 0 at the bottom, so it's not going to be interesting. 4 goes into 0 0 times over and over and over again. So instead, we finish up by lifting our decimal point straight up, and we get that 15 divided by 4 is 3.75. If the number we are dividing was a decimal number to start with, (12.8) divided by 5. Well, the process is going to look the same. It's just that we don't have to decide that we're going to treat this as a decimal number because it's already there. 5 fits into 12 twice. 2 times 5 is 10. Subtract that off and you get 2. Drop down the next digit, which is an 8. 5 fits into 28 5 times. 5 times 5 is 25. Subtract that off and you get 3. Nothing else to drop down, so we do the same trick we used before. Introduce an extra 0. 12.80 is the same thing as 12.8. But this way it gives us an extra 0 to drop down, so we can continue and say 5 goes into 30 6 times. 6 times 5 is 30. Subtract that off, you get nothing. So we can lift our decimal point straight up and see that 12.8 divided by 5 is 2.56. Things get tricky here when you're trying to divide by a number that already has a decimal point in it. Sorry, that's not very clear. I want 3.9 divided by 0.75. This is a little bit tricky. It is possible to set this up using long division without anything else happening, but decimal points are going to get lost along the way and it's going to be a headache. So instead of trying to do that, I want to think a little bit about 3.9 over 0.75. Notice here, if I multiply numerator and denominator by 100, I get 390 over 75. And the advantage to having done this is now I have a fraction that does not have a decimal point in it. We can jump immediately to the long division. Although if you take the time and you try to reduce this fraction before you do so, you actually will save yourself some time and headache. So I'm going to go through this long division first. 75 fits into 390. Well, 75 does not fit into 39, so we just have to go straight away. 75 times 2, 150, 225, 300, 375, 450 is too big, so that's 1, 2, 3, 4, 5. 5 times 75 is 375, and if we subtract that off, we get 15. Insert a decimal point so we can put another digit in that we can drop down. 75 fits into 150 twice. 2 times 75 is 150. Subtract that off, we get 0. There we have it. Move our decimal point straight up. And we get that 390 divided by 75 is 5.2, which means that 3.9 divided by 0.75 is also 5.2. Now the trick I mentioned, 390 over 75, it jumps out to me immediately that top and bottom of this thing are divisible by 5. And if you take the time to do that division first, you see that 390 over 75 reduces and becomes, let's see, 390 divided by 5. 7 times 5 is 35, that's 40. 5 times 8 is 40. And then $15 in the denominator, 78 over 15. That's much easier to work with. And if you really want to go crazy, you might notice that these are both divisible by 3. So you can reduce the fraction further. Three goes into 78, well, 3 goes into 7 twice, 2 times 3 is 6. 3 goes into 18 6 times. And 15 divided by 3, you should know offhand, is 5. So we end up with 26 over 5. We've reduced the fraction, and if that's what you care about, then hooray. But we've also made it so that the division that we end up with is a lot easier. Right. This process involves doing more long division, but each step along the way is long division with smaller numbers and easier to work with numbers. This particular problem was such that may or may not have been worth it, but I think you can see if we get with bigger or bigger numbers, making the numbers smaller so that you can do easier long division is going to be more and more worthwhile. One more problem before we wrap up our discussion of division. 1 divided by 3. Well, 3 does not fit into 1. So we put in the decimal point and add a 0. 3 fits into 10 3 times. 3 times 3 is 9. Subtract that off, you get 1. All right, we have a remainder, so put in an extra 0 so we can drop it down. And we have 3 goes into 10. Weren't we just here? 3 fits into 10 3 times. 3 times 3 is 9. Subtract that off, you get 1. All right, we have a remainder, so add a 0, drop it down. And weren't we just here? 3 goes into 10 3 times. 3 times 3 is 9. Subtract that off, you get 1. There's a remainder, so add a 0 and drop it down. Weren't we just here? 3 goes into 10 3 times. 3 times 3 is 9. Subtract that off, you get 1. There's a remainder, so add another 0 and drop it down. Now we have 3 goes into 10. Weren't we just here? 3 goes into 10 3 times. 3 times 3 is 9. Subtract that off, you get 1. Again, and again, and again. This is what's known as a repeating decimal. You get the same thing happening over and over and over again. We represent the fact that this 3 is happening over and over again by putting a bar over the number 3 in the decimal. This is what's called a repeating decimal. This particular problem has a single digit 3 repeating over and over again. So we write just that single digit of 3 in our repeating decimal number. If I had 27 divided by 11, well, 11 fits into 27 twice. 2 times 11 is 22. Subtract that off and you get 5. Put in a decimal point and a 0 so we can drop that down. 11 fits into 50 4 times. 4 times 11 is 44. Subtract that off and you get 6. Put in another 0 so that we can drop it down. 11 fits into 60 5 times. 5 times 11 is 55. Subtract that off and you get 5. Put in another 0 so we can drop it down. 11 fits into 50 4 times. 4 times 11 is 44. Subtract that off and you get 6. We're going to see this repeating over and over again. The 2 in front is a little bit weird, and then we have a 4 5 4 5 4 5 over and over and over again. One more example of repeating decimals. (17) divided by 6. 6 fits into 17 twice. 2 times 6 is 12. Subtract that off and you get 5. Add a decimal point so we put in a 0 and drop it down. 6 fits into 50 8 times. 8 times 6 is 48. Subtract that off and you get 2. Add a decimal point so we can drop it down. 6 fits into 20 3 times. 3 times 6 is 18. Subtract that off, you get 2. Put in another 0 so we can drop it down. 6 goes into 20 3 times. 3 times 6 is 18. Subtract that off, you get 2. We've been doing this over and over and over again. We get this repeating digit of 3, but it's not the first digit in the number, which is a little bit weird, but that's okay. All right, so the 2 before the decimal point does not repeat. The 8 after the decimal point does not repeat, but the 3 does repeat, and it just keeps repeating the number 3 over and over again. So we put the repeating decimal bar above the 3 in this case. There's a couple of different ideas on how you can deal with repeating decimals, which can and will show up in problems involving division of decimal numbers.